Chapter 2 of A Natural Approach to Chemistry, Matter and Atoms. Section 1, Matter and the Elements. Have you ever wondered what things are made of? Looking around an everyday classroom, there are many different types of materials. You may have tables and chairs made using a combination of wood, metal, and plastic. How many different substances can you identify in this picture? A plant, coal, and you are mostly made of one type of material, carbon. The stuff that we are made of is called matter. In chemistry, we study how one kind of matter can be changed into a completely different kind of matter. Pretty fascinating stuff. A substance is a kind of matter that cannot be separated into other substances by the usual physical means, like heating, cooling, filtering, drying, sorting, or dissolving. Can you think of other substances in addition to corn oil? A mixture contains more than one substance. For example, oil and vinegar are each substances, but when we mix them together to make salad dressing, we have, a mixture. Is pure orange juice a pure substance? It's actually not, because it has several different ingredients like water, sugar, fruit pulp, and other chemicals. Pure orange juice is, therefore, a mixture. Describe something around you right now. What is it made of? Can you list some of its physical properties? Physical properties can be measured or seen. They're directly observable. If I say the sky is blue, I'm describing a physical property of the sky. Related to physical properties is physical changes. These are also observable changes, including changes in shape, phase, or temperature. For example, here we see metal in one form, then arranged into a horse shape. This is a physical change because it's changed shape, but it's still a metal. The snowman melts, which is also a physical change. In both cases, the change involved does not change what the substance is made of. Physical changes include heating, cooling, melting, freezing, boiling, dissolving, bending, and evaporating. Chemical properties are observed when a substance actually changes into a different substance. Iron rusting is a chemical change because the iron metal is turning into an iron and oxygen compound instead. 4 typical signs we would look for that show us a chemical change might have occurred is gas formation, solid formation, color change, or temperature change. When we are working with different types of matter, we need to take into consideration what scale we're observing it on. We usually categorize things as macroscopic, large enough to see with the naked eye, or microscopic, things too small to see without equipment that allows us to do so. Just to give you an idea of how small an atom really is, there are 200 million atoms in a single grain of sand. That's pretty small. Each individual element is a unique type of atom. An element is a substance that cannot be separated into simpler substances by chemical means. All oxygen atoms are the same as each other, but oxygen atoms are different from other element atoms like silicon or potassium. We usually think of a single grain of rice as pretty small, but even its mass is much, much larger than an atom's mass. Just look at this comparison. How could we organize different elements? Well, we sort them by grouping like elements together, and those that behave similarly to each other should be grouped together. The periodic table gives us an organized view of all elements that exist. Let's look at three in particular: lithium, sodium, and potassium. All three of these elements easily form compounds with oxygen. In fact, all three like to form compounds in a 2 of it to 1 of oxygen ratio. The periodic table organizes elements according to their chemical properties. The periodic table also lists information about each element, including its element symbol and its atomic number. We read the periodic table from left to right, top to bottom. It's arranged in increasing atomic number order. Hydrogen is the lightest element with an atomic number of 1. Uranium is the heaviest naturally occurring element with an atomic number of 92. There are elements after uranium, but they're all synthetic. People create those elements in a laboratory. We cannot find elements beyond uranium in the natural world, or at least not yet. Elements in the same column are called groups, and those elements share similar chemical properties. They behave the same and are often called families. Rows on the periodic table are called periods. There's another number listed for each element on the periodic table. This number is not a whole number, and it's called the average atomic mass. This number has units of grams per mole and is based on the AMU, or atomic mass unit. The AMU is equal to the mass of 1 proton. The AMU, or atomic mass unit, is the mass for one atom. For hydrogen, the average AMU is 1.0079. This number is also how much mass in grams would be in 1 mole of those atoms. Are you confused yet? Let's look at carbon. The element symbol is a capital C. The atomic number is 6. What is carbon's average atomic mass? How much mass would 1 mole of carbon atoms have? We'll revisit the mole concept again on another day. For now, you should know that a mole is the number of carbon-12 atoms it would take to have a mass of 12 grams. The mole is a really big number. We use moles to help us count atoms in lab because we would never count individual atoms of a substance. We would just place it on a balance and record the mass. We use atomic masses as a way of knowing how many atoms we're dealing with when we measure mass in lab. One type of calculation we'll be doing a lot is converting grams of a substance, like we measure in lab, to moles of that substance, which we'll need for other calculations. Here's how we set up that type of problem. Don't worry, you don't have to master this yet, but I do want you to be familiar with it. We're given that we have 100 grams of sulfur, and we want to know how many moles that is. From the periodic table, we can see that sulfur has an atomic mass of 32.065 grams per mole. Let's use that atomic mass as a conversion factor. We start by writing what we're starting with, or what we know, in this case 100 grams of sulfur. Then we'll use the atomic mass of sulfur to convert. We want to cancel grams, so we need grams on the bottom of our conversion factor. We put moles on the top of the conversion, and after doing the math, we end up with an answer of 3.12 moles of sulfur atoms. Now we have a problem that gives us the number of moles, but wants us to find the number of grams. How would our problem solving here differ from the last problem? What is our conversion factor? In this case, we want moles to cancel, so we would write moles on the bottom of our conversion factor and place grams on the top. After doing the math, we see that there are 100.2 grams of calcium in 2.5 moles of calcium atoms. In summary, Physical properties can be seen and measured, whereas chemical properties are only observed when one substance is changed into another. Elements are organized by chemical properties into the periodic table. An element's average atomic mass allows us to convert from grams to moles and from moles to grams.